Hi, this is fourth in the series of lecture of work power energy, and here we're going to talk about conservation of energy and idea of potential for energy. So let's imagine we have a ball that falls from a height of about 50 meters. So that's h. So that's about 50 meters. So let this ball, as this ball falls down, let's mark various positions, and it as it falls down, let the distance it falls be denoted by x. So if it falls at this distance, the distance that the ball is above is given by h minus x. So this is point A, and your x equal to 0. Point B, x is 10, 20, 30, 40 and 50. So C 20, D 30, E x is 40, and F, which is x equal to 50. And your h minus x is going to be here, h minus x is going to be here is 50, 40, 30, 20, 10 and 0. So this is the height the ball is above, and this is the height above the ground, and this is the height the ball is from the top, right? Now, what is the kinetic energy at each of this point? So the kinetic energy at any point is given by half m into velocity square. As a ball traverses a distance of x as it comes down due to the gravitation force, there's a gravitation force, and the kinetic energy is going to be half into mass into velocity squared, is u is 0 initially, and your v is v. So velocity squared is going to, you can get it, v squared is u squared plus 2g into x. This u is 0, so that's equal to half m into 2gx, that is equal to mgx. So your kinetic energy at any point is given by, your kinetic energy is at any point is given by mgx. So initially the body is at rest, so it is 0, and here your, let's say your mass is 1 kg, so your gravitation force is mg, that is equal to 10 Newton. So here your kinetic energy would be mg x, which is 10 into 10, 100 joules, and here it would be 10 into 20, 200 joules, and similarly here 300 joules, 400 joules, and 500 joules. So we know that this kinetic energy is a effect, and the cause is your gravitation force, right? So let's draw this in the graph. Let's draw this in the graph of energy versus position. 20, 30, 40, and 50. So this is your A, which is your here is we are denoting this as your h minus x, So this is your meters. So it is about, at A it is 50 meters, at B which is 40, at C which is 30, D which is 20, E 10, and F 0. So as it reaches F, you got the maximum kinetic energy: 100, 200, 300, 400, 500. So this is the max kinetic energy at F, which is 500. So this is a energy. And at A, which is a minimum, which is 0. So your graph is going to look like this. This is your kinetic energy. This is your kinetic energy at each point. $100, $200, $300, $400, and $500. So that's your kinetic energy at each point. That's 400, 300, 200. So that's your kinetic energy graph. Now, what does law of conservation tell us? The law of conservation tells us is that what it tells us, your energy, net energy, is conserved. That's energy is transferred from one form to another. So that's what it says. Your net energy is conserved. So if you want to apply the conservation of energy, so if we assume that this is our net energy, so this is our net energy. So if this is our net energy, so initially we have a total of 500 joules, but if you go to point E, you have only 400 joules. So there is a deficit of 100 joules. There's a deficit of 100 joules. And here there is a deficit of 200 joules. Here there is a deficit of 300. And here that's about 400 joules. And at this point that's about 500 joules. So here is 100, 200, 300, 400, and that's 500. So this deficit of energy, which is for us to apply the law of conservation of energy, that is, the net energy is constant, which is 100 plus 400, 200 plus 300, 300 plus 200, so which is all same. So to introduce the idea of law of conservation of energy, we have come up with a concept of, in physics, called potential for energy. Usually people call it as potential energy, but it is better expressed as potential for energy. So what is this potential for energy? So imagine you have a ball, the same scenario where you have a ball and the ball is dropped from a height h. We define that your potential energy at this point, at this height h, we define the potential energy is mgh. And of course you know that your kinetic energy is, or mg kinetic energy initially is 0. At any point in the middle, as this ball falls down a distance of x, and this height is h minus x. By definition, we say the potential for energy at this point is mg into h minus x, and your kinetic energy is mgx. Of course, it comes from all our previous derivation, which we have looked at. Y is kinetic energy is equal to mgx, and it comes from basically this equation, right, which we have seen here before. So kinetic energy is mgx, and as it falls down, comes to the bottommost point, your potential energy becomes 0, and your kinetic energy becomes mg into h, which is the max. So the way we imagine this is, hey, initially the system has 500 joules of energy, which is 500, and then you have kinetic energy is 0, so this is your k, and this is your represented as potential energy is always represented as u. So u is 500 and k is 0, and at this point let's say this is at midpoint, which is at 25 meters, this is 50 meters, sorry. Same scenario as before. This is 1 kg, right? So your u here would be 250 joules, because at 25 meters, so that's about that's mg into 25, that's 250 joules if mg is 10 Newton. So this is your u, and then here you have the kinetic energy. K is again 250 joules in this case, so they add up to 500 joules. And at this point your u is 0 and your k is 500 joules. So your total energy, we call it as a total mechanical energy, is given by kinetic energy plus the potential energy. We call it potential energy, but it's actually potential for energy. Okay, so keep that in mind. So kinetic energy is your mgx, potential energy is mg into h minus x, so that's equal to mgh, right? So the idea of potential for energy is introduced in physics so that we can apply law of conservation of energy. So, and it is not potential energy, but it is potential for energy. So there's a lot of potential for energy when the ball is at height h and you drop it, and all the potential for energy gets converted into the kinetic energy. So that's the way to look at it.